So there was a question about the nature of the sort of two configuration life, the dual life of P. Okay, so remember P N dA equals T dA, right? Where on the right hand side we have a force. So we have our reference configuration. We have our normal vector n. In fact, we have the area, right? We have the area vector. And now we have our force, okay? Before I draw the force, I'm going to show you what this thing looks like in the current configuration, right? We have here little n dA. This is omega sub t. And we have a basis for all this. The question that was asked was, it's clear enough to understand why this area vector, in the case of P, this area vector, it's clear enough to understand that it is on the reference configuration. In this case, right, here, whereas in this case, it is on the current configuration. Now, when we talk about the force, when we look at the force applied here, let's suppose that this is TdA, Td little a, right? Again, it's clear enough to understand that it's on the spatial configuration. But when we bring the force and we say that it's the same force acting on the reference configuration, isn't that force also then in the reference configuration? The way to understand this, and I understand the possibility of confusion here, but the way to understand the force here is the following. The force is a spatial force. That's where it exists. Okay? Now you remember a fundamental property of a vector in space is that you can move it around. This is not a position vector. Okay? So when this vector goes there, we call it TdA. It's the same vector which we're now moving and bringing out here. Right? It just so happens that we've pasted it to the reference configuration. We've attached it to a point on the reference configuration, but it is still a vector that was living in space and brought here. Okay? So it is in that sense that we say that a vector is a spatial vector. Okay? Unlike NDA, we can't talk about NDA unless we first talk about the tangent vectors on that surface and take their cross product to form NDA. And in order to talk of those tangent vectors, right, if we do something like this, right, we say that this is my surface area. Okay, I need to first say that, okay, I've scribed these two tangent vectors on that surface. I'm taking their cross product to then give me capital NDA, right, which is perpendicular to everything that you see there. Okay? In this sense, the area vector is properly obtained from the reference configuration. It's effectively scribed on the reference configuration. This force vector was really a spatial vector which we just translated and moved around and stuck here on the reference configuration. It's in this sense that we say that the force is a spatial object. Same thing here. We have this body in the reference configuration. It's only by looking at the reference configuration and looking at tangent vectors on it, taking their cross product, that we can now say that, all right, we have a normal or an area vector there. Okay, same thing with the current configuration. We have that as the area vector. When we apply the force, remember the force is not a position vector. It does not depend upon anything like that. So we have a force. I'm telling you, that's the force I want to apply. You may choose to now move the thing to this region in space, to the configuration, right, which is to that region of space that was occupied by the reference configuration, and say, okay, it's working here now. It's still a spatial vector. Okay? Same deal here. Okay? We apply it to the current configuration, it's still a spatial vector which is moved around and brought here. Okay? Underlying this is also the idea that when we talk about the current configuration, what we mean by the current configuration is, remember how we used to do it early in the early units. We used to say it is this region in space. All right? When we say the body is there, it is just that now the body coincides with that region in space. And so that is the current configuration. You may also have noticed that I often say spatial configuration in place of current configuration. Okay? So it is that idea. It's a region in space, okay, which the body happens to occupy right now. Right? So that is the somewhat subtle nature of why the first Euler-Kirchhoff stress really does live in two configurations. Okay, it'll take some thought, but work on that. Okay, you can always come back to this this segment with this question, with this answer, and think about it a little more. Okay, the critical idea is that the force is a vector in space. Okay, it may live. It lives in space always. You may bring it to that part of space occupied by the body in its current configuration, or we bring it to that part of space occupied by the body in the reference configuration. The vectors, the area vectors are fundamentally different. You need to go to those configurations to see what the area vector is in this case, or in the case of the current configuration. Okay? All right. The rest is best done through dwelling upon it.